Good morning, mathematicians. This is Miss Lehman. We are going to talk about what we call the area model of division. We've talked about some area models for multiplication. So now let's talk about this particular problem and how we could use the area model to solve. We see that the dividend is 1,145, and we're dividing that into 35 groups. I asked one of you to give me a context for this problem because, again, when you picture what's happening in the division problem, sometimes it can help you to correctly think about what to do with those particular parts. So I heard a student suggest that we pretend in this problem we have 1,145 pieces of candy, and we are going to sort them into 35 treat bags. Well, in the area model for division, the first thing that you want to do is actually go to the top and do a little brainstorm with your divisor. Our 35 math facts was certainly nothing that you memorized in third grade. We did not memorize our 35 times tables, but I can use just some number sense to think about the particular divisor of 35. I know that 35 times 1 gives me 35, identity property of multiplication. Well, if I know that 35 times 1 equals 35, I know that 35 times 10 equals 350. Here's my basic fact. 35 times 1 equals 35, but then there was one zero outside of the basic fact, outside of those factors. So I add that to the end of my product. We talked about and we made sense of this basic fact with zero trick back in our multiplication unit, and certainly we're going to apply that to this unit as well. Now, let's continue our list. If I have 35 times 2, I know that that gives me 70. I double 35 and I get 70. If I know that 35 times 2 equals 70, then I know that 35 times 20 would give me 700. Again, we're applying the basic fact with zero trick. Now, it's really not a trick. It's just math. It has to do with those powers of 10 and place value, just like we discussed back in our multiplication unit. Well, let's do one more row. If I know that 35 times 2 was 70, I know that 35 times 3, I can add 35 to 70, and I find that 35 times 3 equals 105. Well, 35 times 30 would therefore give me 105 with a 0, so that would be 1,050. Okay, at the very top, the first thing that we do is we brainstorm with our divisor, thinking of some basic facts that we can refer back to as we do our problem solving. Now, the second thing that we're going to do is we're actually going to come down and we're going to begin modeling this with the area model. Remember what we've discussed. This rectangle represents my dividend. So in this problem, because of the context that we made up, this rectangle represents 1,145 pieces of candy, and that candy is going to be sorted among 35 treat bags. This problem is looking pretty good to me. Well, the first thing that we're going to do is we're going to ask ourselves, what would be a reasonable number of candy that I could go ahead and put inside of all of those 35 treat bags? Go back to your basic facts. We want to get as close as we can to utilizing this 1,145, but certainly we can't go over that. We don't have enough candy to go over that. This is the amount that we have. So go to your basic facts. If I took one group of 35, that would only be taking 35 of this very large number. That's certainly not enough. Let's continue to go up and we see, wow, we can actually take 30 groups of 35 in one fell swoop at the beginning. 35 groups of 30 is going to use up 1,050 pieces of candy. Okay, imagine it. The treat bags, all 35, now have 30 pieces of candy in them. I used 1,050 pieces of candy to do that, and now I'm going to subtract, and I'm going to find out how much candy do I still have to sort among my treat bags. All right, I still have 95 pieces of candy to sort among those treat bags. This 95 is going to rise to the top because this 95 now represents how many pieces of candy we still have to sort, right? So let's go back to our basic facts. Again, we can't go over 95, but we want to use as much of this candy as possible in this next step. So coming up to the top, if I did one group of 35, so one piece of candy inside each treat bag, I'd only use 35 pieces of candy. That's too little. If I gave each treat bag 2 pieces of candy, though, that would use up 70 pieces of candy. That looks pretty good. So here, we're going to take 2 pieces of candy to put inside of each of the 35 treat bags. When I do this, I'm going to use up 70 pieces of candy. Okay, I couldn't do 3 pieces in each treat bag because I don't have enough for that. This was that just right number. Now when I subtract, I'm going to get a difference of 25. I go back and I compare. If I have 25 pieces of candy still left, would I have had enough to go and give each of the 35 treat bags an additional piece of candy? No, I would not. I don't have enough for that. I can't equally share it. And division is all about equally sharing. Therefore, this 25 becomes my remainder. Now, 25 is a pretty big number to have as a remainder. But boys and girls, just like we've discussed in class, it really has everything to do with comparing it to this divisor. If it's less than the divisor, it's an acceptable remainder because just like in this candy conundrum, we wouldn't have enough to give all 35 bags an additional piece. Okay, so now let's go back to our initial problem where we started. And let's think, how would we express this as the answer? Where do we see the answer in our model? We started with 1,145 pieces of candy. We sorted them into 35 treat bags. How many ended up in each treat bag? Well, certainly the whole rectangle represents our dividend, 1,145. The outside represents our divisor. This was the treat bags that we sorted into. This represents my quotient. When I combine the two numbers on top, 30 and 2, I see that each treat bag ended up with 32 pieces of candy, and we need to say that we had that remainder of 25.